So that is the graph that actually we are given. And then here, on the turning point, it's graph number B. It's point number B, so to say. Then here they're giving us to say that is 2 and 0. Yeah. And then this point here, which represent the y-intercept, is going to be 0 and 12 based on what we are actually given. And then here, we are having that being A. Don't forget to say that will represent your y-axis. That will represent your x-axis. That's how basically it is. And then they're giving us the equation. They're giving us the equation f of x. It's equals to what? It's equals to x minus x squared. So it's x cubed minus x squared minus 8x plus 12. So the equation that we're given is x cubed minus x squared minus 8x plus 12. And then they're basically telling us to say, calculate the coordinates of A. So when you look at the coordinates of A on the graph, A represents the x-intercept, right? So using the concept of the remainder and the factor theorem, remember when they want us to calculate the coordinates of A, there are many ways in which one can do that. You can use synthetic method. I prefer using long division method. You can use also K method, it doesn't matter. Take in consideration that at least here, they're giving you one of your factors as 2 that represents the x-intercept. And then you understand that this 2, it comes from x minus 2, it's equals to 0. This basically means to say, I'm going to use x minus 2 if I'm going to use long division method, right? And then I'm having what? I'm having x cubed. You write it there. Minus x squared minus 8x plus 12. Remember, when you use long division method, I'm going to use DMSD. So I'm going to start by dividing. So you're going to say x cubed divided by x, that is x squared. You write x squared there. And then you multiply. So it will be x squared times x, that will be x cubed. Then x squared times minus 2, that's minus 2 x squared. Then now you subtract. Remember, when you subtract, you put them up brackets so that you don't make mistakes. Ne? So x cubed minus x cubed, it's 0. And then negative times negative. Negative times negative is positive. So minus 1 plus 2. That should be, what is minus 1 plus 2, guys? That should be what? That should, it will be x squared. Do you all see? Because remember here, let me show you. Sorry for that, I was just adding some few people. So coming back here, it's negative times negative, that should be positive. And then minus 1 plus 2, that's 1. So it's 1x squared. So you're going to write x squared after subtracting. Then you're dropping. So when you're dropping, you're having negative 8x. You're going to take it and then you're going to drop it here. So that will be minus 8x. And then after that, you go and divide again. You're going to say x squared divided by x. That should be what? That should be positive x. Gonna write positive x. Then we say x times x is gonna be x squared, right? You write it there. It's gonna be x squared, you write it there. Then you say positive times negative, it's negative. So you're gonna get negative 2x. Then after that, now you're gonna subtract. So as you subtract, you put them up brackets. So x squared minus x squared is 0, we all know. And then negative times negative, it's positive. So minus 8 plus 2. Minus 8 plus 2, I think, sorry for that. Minus 8 plus 2, I think it's minus 8 plus 2. It's minus 6. You're gonna write minus 6x. After subtracting, then you drop that, positive 12. And then you go again, minus 6x divided by x, it's minus 6. Write negative 6. And then you multiply negative 6 times x, that's negative 6x. And then negative times negative, that's positive. 6 times 2, that's 12. I think we are working on the correct side so far. So this should actually give us 0. That is going to be 0. And one thing that you need to understand, just because of the question wants us to calculate the coordinates of A, you ask yourself a question. What represent the coordinates of A, K, x-intercept? And then here, for the mere fact that they actually gave us to say our x coordinate is going to be 2, it means to say, even though I'm finding the coordinates of A, since this is a long division method and I'm determining the coordinates of the x-intercept, it means to say this one that we actually had from the original onset, we're gonna get it again. And then the one that we'll basically be looking at is this one, whereby we're gonna get the x-coordinate of A being negative, because you can actually see that here, even though I didn't write it, but according to the Cartesian plane, I think it makes sense. That is the point of origin being 0. And then you know that going where there is the value of A, you know that all those x values, they are negative. So that's how basically gonna interpret it. Ne? And then taking into consideration that now we are having x minus 2, as you can see, as well as this quadratic equation, which is x squared plus x minus 6. I'm going to say equals to 0 here. Then now you factorize. Remember, this is going to be x minus 2 equals to 0. Or then now you factorize. So when you factorize, you open two brackets. You look at the factors of the last term, which is 6. So here, remember, it will be x. Even there, it's going to be x. So you look at the factors of the last term being 6. When you multiply them, they give you the last term 6. When you add them, they give you the middle term, which is 1. I think that's 3 and 2. Because 3 times 2 is 6. Ne? And then it should be positive 3 together with minus 2. So here it's equals to 0. And then therefore, here you're having x is equals to 2. Or, remember, this will be like this, x plus 3 is equals to 0. Or x minus 2 is equals to 0. That's how basically it will be from the original onset. Then from there, as you now continue, therefore, the value of x is going to be equals to negative 3. Or x is equals to 2. And then now look at this. This is x is equals to 2, it makes sense. This is x is equals to 2, it makes sense. So while I was teaching you the basics of differential calculus, I actually showed you to say the reason why we are getting two x values being x is equals to 2 being the same. I told you to say one represents the x value of the x-intercept, the other one represents the x value for the turning point. And then I told you to say, when you go back to where I was teaching you the concept of the theory of graphs, I made it I made it a point to show you three different formulas. And then I said, if the graph is like this, it's gonna have two answers which are gonna be the same. That's why here you must not be surprised to say you are getting x is equals to 2, you're getting x is equals to -3, you're also getting x is equals to 2. You know why? As I've just also emphasized, I told you to say, since now we are looking at finding the x-intercept, I told you while I was calculating to say one answer must be x is equals to 2, because you know that this is a coordinate that's represented by x and y. So we are not concentrating on the zero part because we are looking at finding the x-intercept. So there was a reason whereby I was telling you to say you're gonna get the other one, which is 2, because from the mere fact we are being given it here that is 2. And then I told you to say the other one, based on the point of origin being 0 there and then where A is being situated, I told you to say the coordinate of A is gonna be the answer that is negative. That's why here when you are now calculating, or when you are now done calculating, you can actually locate to say you are having x is equals to -3. It means to say, just because of the coordinates of A, it's represented by x and y. Not only that, let's go to the Cartesian plane. Let me show you something. Not only that, one thing that you need to understand is that on the x-axis, y is always 0. And then on the y-axis, x is always 0. But just because of they want us to calculate the coordinates of A, based on what I was just explaining to say A, it will be represented by x and y. Not only that, look at the point of origin where we are having 0. Look at the position where A is being positioned. You can actually see that A is positioned on the left-hand side of the point of origin. It means to say, with regards to the coordinates of A, it must be any number that is negative. That's why you got an answer that is negative. So our coordinates for A, the one that are accurate is what? We got -3. So it will be -3 and 0. Yes, it's on the minus side. It's on the minus side. So it's gonna be -3 as well as 0. So that is what the question wants us to do. Not only that, we are done with that one. The what? The second part, they say calculate the x value, the x coordinate of B. So when they want us to calculate the x coordinate of B, you look at B. So B is it's representing the stationary point, or it representing the turning point. And then who can tell me how do we get the x coordinate of B? Who can tell me how do we get the x coordinate of B? The question is one and the same thing with me asking you to say, how do you find the turning point? Because that, yes, it's a turning point. How do you get the coordinate of B? Because the x value of the coordinate of B, it represents the turning point. So me asking you to say, how do you get the x value of B? It's kind of like me asking you to say, how do you get the turning point?
What differentiate and then after, yeah.
What differentiate and then after, Juliet?
What differentiate like that,
Yeah,
and then after on your then you can the x intercept your opinion, and then what is substitute go the original for me.
yeah, correct. That's 100% correct. So to those who don't know, for you to get the x value at B, B represents the stationary point or B represents the turning point. It means to say you're going to take the original equation of a cubic function, you differentiate it once. And then after differentiating it, remember, this is a cubic function. The moment you differentiate the cubic function, it now tends to become a quadratic formula. That's why after differentiating a cubic function, we are getting two answers, simply because of we are coming from a perspective whereby we had a cubic function that has three x values. And then when we differentiate it, we are getting stationary points or turning points. It's a must that you're going to get two x values, which represent the quadratic formula, simply because when you look at the cubic function, it has two x-intercepts. It has, sorry. When you look at the cubic function, it has two turning points, so to say. It has two turning points. So the reason why it says two turning points is because of after we differentiate the equation of a cubic function, we're going to get x squared. That x squared is representing us to say we're going to have two answers that represent our turning point. So now let's differentiate that. Now let's differentiate that. So remember they give us uh, remember they give us this equation. I'm trying to use a white color. So f of x, it's equals to what? It's x cubed, right? And then x cubed minus x squared. Let's differentiate. And then minus 8x plus 12. Minus 8x and then plus 12. So one thing that you need to do, you can just say if you want, at any turning point, remember, I told you to say when you are given f of x, it means to say when you differentiate, it will be f prime of x, it's equals to 0. And then now let's differentiate. We're going to say f prime of x, it's equals to, so as you differentiate that, you're going to get 3x squared, 3x squared minus 2x minus 8. And then here you just said at any turning point dy dx is equals to 0. Here, f prime of x, so to say. It means to say where there is f prime of x, you're going to put 0. So it will be 0. It's equals to 3x squared minus 2x minus 8. So you can rearrange it and writing it properly. So we are having a quadratic form, which is 3x squared minus 2x minus 8 is equals to 0. Now, to those who don't know how do you do what to do? And here we are having 3x squared minus 2x minus 8. To those who don't know how to factorize, that is the term that I was looking for. You're going to use a quadratic formula, still one in the same thing. You're going to get the same answer. But to those who are moving alongside with me, as we are factorizing our factors, we now know it's going to be what? 3x plus 4. To that gang, that will be factorizing is 3x plus 4 as well as x minus 2.
2.
Yes, 100% correct. And then you're going to say 3x plus 4, it's equals to 0. Or, now let me teach you maths. Let's go back to our graph. I want to show you something very important. So since they want us to find what? The x value at b. Remember, I'm saying the x value of at b, what does it represent? It represents the turning point. So it's kind of like me saying find the turning point here. So one thing that you need to understand, look at b. It means to say that x value at b, when you can draw a dotted lines like that, you can see that it lies between a and 0. It means to say that x value is at b, number 1. Before you can further calculate that, you must get a negative answer. If you're not going to get a negative answer, you are wrong. Not only that, you're going to get the negative answer together with 2. 2, it must be positive because from the original perspective of the graph, we had 2 in the beginning. It means to say it's a must that one of the answers there, it must have 2. It's a must that the x value at b that they want, it's negative. So those are things which you need to know by heart. That's how we interpret graphs in an easy manner. Then you go back, you continue with what you were solving. Remember here we said what? Or you're going to write x minus 2 here. It's equals to 0. As easy as that. Whilst others are panicking, you don't panic. You say 3x, it's equals to, you take positive 4, transpose it that side, changes the sign to become negative. Not only that, you are solving for x. What do you do when you are solving for x? Math says you divide both sides by 3. Why do you divide both sides by 3? Because math says what you do in the left-hand side to also do it on the right-hand side. That's one thing that you need to do. Not only that, now as you continue, uh, yeah, guys, you know when you are teaching that The devil is fighting us these days. Mina, I don't know. I'm normally losing heart now. I don't know what to do. Hmm. Yeah, I'm no longer knowing what to do now. Okay, let's continue. I hope you'll be able to see. So I wrote something like this. We we had 3x plus 4. Okay, let me do like this because this one is not visible. So this one we had what? We had our x being equals to minus 4 over 3. So it's gonna be minus 4 over 3 or x is equals to what? X is equals to 2. So it means to say the one that they want is therefore x is equals to what? Minus 4 over 3 because I told you to say it's gonna be negative. So that's the one that basically we're having. Just like that. And then the last question, they're saying write the values of x for which the graph increases. Now this one, it will need me to go back and redraw the graph. I don't know. The devil was fighting us so that I don't explain this question for you guys because it's a typical exam question. So now I had to go back, redraw the graph of which, yeah, I'm not quite happy when I'm teaching and then I get disturbed just like as easy as that. I get disturbed a lot. That's what I'm saying. Let's pray for our sessions. So we had the graph which is like this because this graph, it will need you to this question, it will need you to interpret it from the graph. Remember here, we are having the coordinate of b, of which here we got negative 4 over 3. Then for you to get the respective y value, you can substitute that x equals to negative 4 over 3 to the original equation. And then here, remember, we had 2 and 0. We also have the y-intercept here, which was, I think it was 0 and 12, if I'm not mistaken. And then here we got the coordinate of A. What was the coordinate of A? Minus 3 and 0. Was it minus 3 and 0?
Yes, sir.
Yeah, minus 3 and 0. So now, this question is very important. It's a typical exam question. I don't know why the devil is fighting me not to explain this question to you guys. So they're saying what? They're saying write the values of x for which the graph increases. So now, before you can basically answer this question, now you must understand the concept of what is a turning point first. After now understanding what is the turning point, you'll know where the graph decreases as well as where the graph increases. So since they say write down the x values of which the graph increases, we are always going to be guided in our turning points. But before that, let's check where the graph increases. So you go back and highlight. So this graph here, it increases as you can see. This graph right here, it increases. Even right here, it increases. And then on the green part, that's where the graph decreases. On the green part, that's where the graph decreases there. And then on the stationary point, the graph it's just cool. So it increases at the stationary point, the turning point, it becomes 0, then decreases on the green zone, becomes 0 here at the turning point, then it increases just like that. So when they say write the values of x for which the graph increases, so this is what you're going to do. So you can actually see that the graph increases. This side, it increases. So in some instances, or some textbook, they will just say write down the values of x for which f prime of x is greater than 0. Even this one is greater than 0. So your x values are going to be like this. You're going to be guided in a turning point. So the first one, it will be x is greater than what? Greater than 2. Don't say greater or equals to. You're going to be wrong. If you're going to write it like this, greater or equals to, you're going to be wrong because at equals to 2, the graph doesn't increase. It is equals to 0. So that's why I'm saying don't write this one. But the correct one is this one. When x is greater than 2, you can actually see that's where the graph increases. Not only that, there is a specific reason why they wanted you to find the x value of b, so that you can get this question correct. They also want another x value where the graph increases. Anish, we'll just say where x is less than -4/3. That's where the graph increases. Because when I'm saying -4/3, when it's less than this zone, do you see that's where the graph increases? So you can basically write it like that to say, since they say write down the values of x for which the graph increases, you'll tell them to say the graph increases when x is greater than 2, or the graph increases when x is less than -4/3. So that's how basically we deal with this question. And then if they can say write down the values of x for which the graph decreases, you can actually see that the graph decreases when x is less than 2 or x is greater than -4/3. Just like that. This one, that's where the graph does what? It decreases. Yes, concave up and concave down. And then when they can say write down the values of x for which f prime of x equals to 0, it means to say your values of x, it will be x is equals to -4/3, as well as what? X is equals to 2. Because at 2, the graph is stationary. It does not increase, it does not decrease. So when you look at this approach, it increases, becomes 0 here at the turning point, it decreases, becomes 0 here at the turning point, it increases just like that. So this question, you can't run away from it. It's a typical exam question. And they're going to ask you where they talk about domain and range, because they know that a lot of you guys are struggling with regards to finding the domain and the range. So I just wanted to teach you these 3 questions to say, each and every time they say write down the values of x for which the graph increases, what should you do? If the graph decreases, what should you do? Just like that. Any question? Any question? Any question? So if there's no question, that's how we conclude our session. Sharp, sharp, guys. Keep on practicing. Tomorrow, I'm gonna teach you application of calculus. So I want you to know all these questions in using all different types of angle. So tomorrow, calculus application. Sharp, sharp.